Arithmetic is used heavily in sewing and crafts. In this video, I will focus on arithmetic used in creating fabrics and quilting. Before we proceed, we need a little background. Do you know multiples have a visual element? We can see it clearly in this 3D environment I built. Below us are squares of two different colors. White means non-multiple, and black means it is a multiple of the number indicated in the top left. If we give every square a number from left to right, top to bottom, black means the number is divisible. What happens when I change the number of rows? See how we get a cycling pattern? For 2, we get a striped or checkerboard pattern. For 3, there's a cycle of 3, diagonal to the left, diagonal to the right, then stripes. Similarly, 4 has 4 unique patterns. Five has 5 unique patterns. We can do this with any number, and the rows provide new patterns. What we are viewing is multiples visualized in a grid. We can use these ideas for inspiration in quilting. If we wanted a patchwork quilt to be more organized, this grid provides inspiration to do so. Count the total number of squares you plan to use in your quilt. Separate them by a color or pattern or both. Identify how many unique squares you plan to use. That becomes the number we skip count by. The number of rows is determined by how many available squares we have or how long and wide we want the quilt. It is a simple concept but powerful in designs. This also works for tiling bathroom, hallway, or kitchen. This multiples pattern can be applied to anything laid out on a grid. It's also applicable to the weave of fabric, but some arrangements are impossible or need modifications to accommodate. This 3D animation shows a common weave, under, over, under, over. If it's filled out far enough, we get a checkerboard pattern. However, we get this checkerboard pattern regardless of how many rows we start with. This is because we loop around the end thread, which reverses the pattern on the second row. This doesn't need to stop us from venturing on, though. If we consider the forward weave and the backward weave to be one cycle, when we start on our next row, we can choose to offset by 1 or start on the edge. If we offset by 1, we get a checkerboard pattern that repeats every 2 cycles. If we do not have an offset, the cycle repeats immediately. This means we can treat the first and last strands as a border. Doing so allows for the flexibility we need to see the multiples patterns show up here too. With a bit of flexibility around the first and last strands, we can do a weave like over the first thread under the next 2. This creates the diagonal stripe we saw with multiples of 3 offset by 1 row. We can also reverse the direction. Using a combination of multiples and other weave techniques, we can create beautiful woven patterns. The other techniques include mathematical concepts, but generally have their own names. Remember, this is a math course, not a sewing course. What I'm trying to show is that the math allows for flexibility and experimentation. Sometimes we get stuck learning terminology and phrases. Though this is helpful, it is not necessary to get started. I'm of the opinion that terminology will eventually come. Starting is more important than accurate terms. Learning to weave simply from a weaving standpoint will eventually have the flexibility, but often comes after years of practice. Letting mathematics inspire gives us a chance to understand why the weave works or doesn't work. The patterns shown in this video are due to multiples. The quilt or weave is highlighting the underlying pattern of multiples. To help further the point, here's a quick program I wrote to showcase the idea. It prints a dash if it's not a multiple and a vertical bar if it is. With each pattern iteration, it adds a single row to ensure we can see all possible patterns with this multiple. Allowing arithmetic to inspire designs can help facilitate understanding. With time and trial and error, we can identify math concepts that apply and which ones don't. This empowers the weaver to create their own tools or find new and unique ways to weave.